On February 17, 2026, SurrealDB released version 3.0 into general availability and announced a $23 million funding round on the same day. Their customer list now includes Verizon, Walmart, Nvidia, Samsung, and Tencent. A database that did not exist 5 years ago is now running in production at some of the largest companies in the world. And it is written entirely in Rust. So if you're building a Rust application and you're trying to decide which database to use, the conversation in 2026 is genuinely different from what it was even a year ago. You have PostgreSQL, the battle-tested 30-year-old relational giant that everyone knows and trusts. You have SQLite, the embedded database that runs on more devices than any other software in history. And you have SurrealDB, the multi-model newcomer that wants to replace your entire database stack with one Rust binary. In this video, I want to give you an honest comparison of all three. We will look at what each one actually is, write real Rust code connecting to each, cover the SQLite ecosystem for each database, and give you a clear decision framework for which one belongs in your next project. Let's get. Before we dive in, I want to talk about Aarambh Dev Hub's partner, CodeCrafters, and this one I actually mean it when I say it is a good one. If you have been watching Aarambh Dev Hub for a while, you already know that we are all about understanding how things actually work under the hood. Not just using tools, but truly understanding them. Why does Redis work the way it does? How does Git actually store your commits? What is really happening when you type a command in your shell? CodeCrafters is built around exactly that same curiosity. CodeCrafters is a platform where you rebuild real developer tools from scratch. Things like Git, Redis, a shell, an HTTP server, a DNS server, a BitTorrent client, you actually build them yourself, stage by stage, in your own language. Every stage unlocks the next, and you can see exactly how far along you are as you go. Now the most popular language on CodeCrafters is Rust, and that makes total sense for this channel. If you're just getting started with Rust and want to learn it the right way, this is honestly one of the best approaches out there. Instead of reading theory or doing small exercises that go nowhere, you sit down and build something real. Something you have actually heard of. Something that exists in the real world. And that is when Rust really starts to click. This is not your typical tutorial platform where you just watch someone else code and feel like you learned something. You are the one writing the code, you are the one debugging it, you are the one making it pass each stage. That kind of active, hands-on learning is what actually makes you a better systems programmer, and I will be honest. It is genuinely a lot of fun. The challenges are used by engineers at companies like Google, Meta, and Shopify. And if your company has a learning and development budget, there is a very good chance CodeCrafters is covered under it, meaning it could cost you absolutely nothing out of pocket. Worth checking with your manager before you pay yourself. The link is in the description below. Check it out, and if you do sign up through it, you also directly support Aarambh Dev Hub, so thank you in advance if you do. Alright, now let us get into the video. Before we write any code, I want to give you a real mental model of what separates these three databases, because I think a lot of comparisons treat them as three versions of the same thing when they are actually solving different problems. PostgreSQL is a relational database. Data lives in tables with rows and columns. Relationships between tables are expressed with foreign keys and joined together with SQL. PostgreSQL has been in development for 30 years. It has the deepest feature set of any open-source database, full ACID compliance, excellent JSON support, extensions like pgvector for vector search, PostGIS for geographic data, and a query planner that has been optimized over decades. It is the safe, boring, proven choice, and being safe, boring, and proven is often exactly what you want. SQLite is also relational, but it is fundamentally different in deployment model. SQLite is an embedded database. It lives inside your application as a library, not as a separate server process. There is no network connection, no authentication, no connection pool. You just open a file and query it. SQLite runs on more devices than any other database in history. It is inside every Android phone, every iPhone, every web browser, and hundreds of millions of IoT devices. For a Rust application that needs local storage without the overhead of a server, SQLite via the Rustclite or sqlx crates is extremely practical. SurrealDB is something genuinely different. It is a multi-model database, one engine, one query language, one binary, but it handles relational data, document storage like MongoDB, graph relationships like Neo4j, time series data, vector search for AI workloads, geospatial queries, and key value storage all at once. SurrealDB 3.0, released in February 2026, is what the team is calling their first truly production-ready release. It is written entirely in Rust, ships as a single binary, runs ACID transactions across all data models, and can be embedded directly in your application, run as a standalone server, or deployed in a distributed cluster. The key question is not which one is best. The key question is which one fits your use case. Quick one. If this is already clearing things up, hit the like button. It helps this reach more Rust developers. Subscribe for more deep dives like this every week. Back to the comparison. Let me start with PostgreSQL using sqlx, because this is the stack I reach for most often for production web services, and I want to show you exactly why. sqlx is the async-first, compile-time-checked SQL toolkit for Rust. It is not an ORM. You write real SQL, and the sqlx macros verify that SQL against your actual database at compile time. If you make a typo, call a column that does not exist, or pass the wrong type, you get a compiler error, not a runtime panic in production. Create a new project and set up Cargo.toml. Let me go through the sqlx features. Runtime Tokyo tells sqlx to use Tokyo's async runtime. This is what makes sqlx work with Axum, Actix, and every other Tokyo-based web framework. The Postgres feature enables the PostgreSQL driver, specifically pure Rust, no C dependencies. UUID enables automatic mapping between Rust's UID type and PostgreSQL's UUID column type. Chrono handles datetime mapping. Macros enables the sqlx query, and sqlx query as macros, which give us compile time SQL checking. Migrate enables the sqlx migration runner. .env is a crate for loading environment variables from a .env file. This is how we pass the database URL without hard-coding it. Now create a .env file. Now src maind nar s. Let me walk through the most important parts. The sqlx from row derive on our structs tells sqlx how to automatically map database rows to Rust structs. Field names must match column names. sqlx uses them to do the mapping. If they do not match, you can use the sqlx rename attribute. The sqlx cower query as macro is where the compile time magic happens. The first argument is the Rust type to map into. The second argument is the raw SQL string. The macro connects to your database at compile time, sends the query for analysis, and the database tells it the types of each column. Those types are then checked against your Rust struct at compile time. If you write select ID, name, email from users and your user struct expects an integer ID, but the database has UUID, compiler error. Not a runtime crash, a compiler error. PG pool options creates a connection pool. Max connections sets the upper limit. For a production web server under load, you might want 20 to 50 depending on your PostgreSQL configuration. The returning clause after insert is how PostgreSQL hands back the newly created row with all its generated values. The UUID from gen random AUIB, the timestamp from now. This is cleaner than a separate select after every insert. Run it with cargo run. But notice, you need a running PostgreSQL instance, and you need to run the migration or the table creation first. This is the operational cost of PostgreSQL compared to SQLite. Now let me show you SQLite. Same SQLx crate, completely different deployment model. No server, no setup, just a file. Change the Cargo.toml dependencies. Notice we switched Postgres to SQLite in the SQLx features. No UUID feature because SQLite does not have a native UUID type. We store UUIDs as text. No external C dependencies for PostgreSQL driver, but SQLite uses the libsqlite3c library. On most Linux systems it is already installed. The senv file changes too. That is it. SQLite creates the file at local.db if it does not exist. The biggest differences from PostgreSQL are visible immediately. No UUID type. We store UUIDs as text strings and generate them in Rust before inserting. No returning clause in the same way. SQLite supports it in newer versions, but it is less universally relied on. The Piragama calls at startup are important for performance. Wall journal mode allows concurrent reads while a write is happening, which is essential for any application with more than one user. The user experience of SQLite in a Rust application is that there is zero infrastructure to manage. You cargo run, the database file is created automatically. Your data is stored. For CLI tools, desktop applications, mobile applications, embedded devices, and small web services that do not need horizontal scaling, this is genuinely. Now let me show you SurrealDB. And I want to be upfront. SurrealDB feels very different from the other two. The query language, the data model, the deployment options, it takes a mental shift to appreciate what it is doing. Add the SurrealDB crate. Just 3 dependencies. SurrealDB's Rust crate handles everything: connection, querying, embedded mode, serialization. Let me explain what is genuinely different here. The Surreal new call starts an in-memory SurrealDB instance right inside your Rust process. No Docker, no setup, no server running somewhere else. For development and testing, this is remarkably convenient. For production, you would use a remote connection instead. The use_ns and use_db calls set the namespace and database. SurrealDB supports multi-tenancy natively. Different namespaces can host completely isolated databases on the same server. The create method inserts a new document and returns the created record, including its auto-generated ID. SurrealDB IDs are record IDs in the format digtable. Unique, so user 7F3A9B12, rather than just a UUID. The relate statement is where SurrealDB does something neither PostgreSQL nor SQLite can do naturally. It creates a directed edge in the graph. User Darshan wrote PostXYZ. This edge is a first-class record in the database with its own fields, not just a foreign key. You can attach metadata to the edge itself, like created AT. The graph traversal query, select wrote post starch, from user, that arrow notation is SurrealQL's way of walking graph edges. The means follow outbound edges named wrote and get the connected post records. This kind of query is genuinely painful to express in SQL with join tables. In SurrealQL, by the way, if you are building something with any of these databases in Rust and want to discuss your approach, come join the Discord community. The link is in the description. We have a weekly Sunday study group where people share what they are building. Really helpful for getting unstuck. Link is below. Let me give you the honest decision framework because this is what actually matters. PostgreSQL is the right choice for applications that need the full power of relational data modeling, complex queries, strong consistency guarantees across multiple tables, and the confidence that comes from 30 years of battle testing. If you're building a financial application, a healthcare system, an e-commerce backend with complex pricing and inventory logic, or anything where your data model is fundamentally relational and correctness is critical, use PostgreSQL with sqlx. The ecosystem is mature, the tooling is excellent, and the community knowledge base is enormous. When something goes wrong at 3 a.m., there is a Stack Overflow answer for it. SQLite is the right choice when you do not need or want a separate server. Desktop apps, CLI tools, mobile apps, embedded devices, small web services that will never need to scale beyond one machine, development databases for local testing, SQLite is perfect for all of these. It is the most deployed database in the world for good reason. With sqlx, it integrates into Rust cleanly, and the wall mode makes it reasonably performant for light concurrent workloads. The constraint is that SQLite does not scale to multiple write processes, it uses file-level locking. For a single Rust binary serving moderate traffic, it is often more than sufficient. SurrealDB 3.0 is the right choice for a specific set of problems that were previously hard to solve with a single database. If your application needs both relational queries and graph traversal, think social networks, recommendation engines, knowledge graphs, AI agent memory. If you need real-time live queries without building a separate subscription layer. If you are building an AI application and need vector search, graph context, and relational data in one query. If you want a database that can be embedded in your Rust binary, run as a lightweight edge service, and scale to a distributed cluster without changing your query code. The SurrealDB caveats are real and worth saying clearly. It is younger than PostgreSQL by a factor of 30. The ecosystem of migration tools, monitoring integrations, and operational tooling around PostgreSQL is vastly more mature. If you have a standard relational workload, PostgreSQL is still almost certainly the better choice. SurrealDB earns its place when you are building something genuinely multi-model or when the graph capabilities or live query support address a specific requirement in your application that would otherwise require Quick one, if this channel has been useful to you and you want to support the work, you can buy me a coffee. The link is in the description. Everything goes toward building these projects and making videos like this. Thank you genuinely to everyone who has already. That is the complete comparison, SurrealDB 3.0 versus PostgreSQL versus SQLite for Rust apps in 2026. We covered what genuinely separates them, built real Rust code for all three with full Cargo.toml explanations, and gave you an honest decision framework. The short version, PostgreSQL with sqlx for complex relational production workloads, SQLite with sqlx for embedded, local, or lightweight deployments. SurrealDB for multi-model graph-heavy, AI-native or real-time applications where its unique capabilities directly address your requirements. If this helped you make a decision about your next project, hit the like button. It takes 2 seconds and genuinely helps this channel grow. Subscribe for deep dive Rust content every week. Drop a comment. Which database are you using in your Rust projects right now? I read every single one. Check out the Rust Aarambh's video on this channel for a deep dive into Diesel versus SQLX versus Aarambh. All three are linked in the description. The Gupti series shows all of this in a real production context. Come join the Discord link in the description. And support the channel via Buy Me a Coffee, also linked. Thanks for watching.